as was introduced, my name is Antonio Fernández Anta, and I'm a professor, research professor. We don't have really teaching duties at IMDEA Networks in Madrid. And this is part of an ongoing effort in which there is a huge team. I mean, the core, I would say, is probably like 30 to 40 people, and we have overall involved more than 200 people helping with different aspects of the project. So it's a pretty big thing. I'm very proud of it. I just wish you would be more helpful. Essentially, this came to birth on March 13th. I had been following what was happening in Italy, and then we started having a surge of cases of COVID-19 in Spain. And at that time, it was obvious that Spain had no resources to be able to test all the cases that were, symptomatic or had, symptoms that were compatible with COVID-19. So on that day, the front page of the main newspaper was saying that Spain is the second country in the European Union with 3,000 plus cases. Okay, these were the number of confirmed cases, but my estimate at that time it was that the whole country was not able to do more than roughly 10,000 PCR tests per day. So how many cases were actually there? The question is, this is just the tip of the iceberg, but there's probably a huge block of ice under the surface. So just as a kind of a toy experiment, I deployed in Twitter this question, like this poll. Well, it's in Spanish, but I guess you can guess what I'm asking about. Is how many people among your friends, your contacts, do you know who have symptoms or have been diagnosed with COVID-19? As you saw, 72%, 73% almost said that they knew no one. 11% said one, 8% said two, and roughly 8% said three or more. So I did a very quick computation. I said, well, assuming each participant knows 150 people, which is this number, the Goomba number, and assuming that when they say three or more is actually three, so I don't overcount, the rough estimate I was getting was 150,000. That's 50 times more than the official numbers. That was on March 14th. The survey was open for 24 hours. And as you see, the number of votes I got, so the number of participants was more than 700. So this had some statistical significance. I mean, essentially the data was, I would assume, rather reliable. Of course, I didn't have any control of who was answering. It could be my friends. There could be people from other areas of Spain. There could be people from other countries. I didn't have any control. In fact, since this conference is on bias, I later discovered that probably this number that I was estimating was biased geographically. Most of my contacts are from Madrid, and Madrid one of the regions that was more severely hit. So probably this number was overcounting just because the responses were coming from a severely affected region. So that started as I said, it started as a toy experiment, and it became a survey in Google Forms. Then it took the shape of a research experiment for which I got the ethical approval of my institute, and is now a survey that is asking people to report indirectly what they know about their contacts in order to monitor the evolution of the pandemic. It's available in more than 60 languages. That's why we got so many people involved in the translation process. It can be answered for all countries of the world, and in 150 of these countries, you can even answer at the regional level. You can, like in Spain, you can even go down to the provinces. You know, we have regions and provinces, so you can go down to the province level. Same in Italy, same in France, for instance. Just to give an intuition of what are we asking for, is just a generalization of this question that I asked in Twitter. So first, you have to choose your region, I mean your country, or your region within the country. Then we ask, how many people do you know personally in that area? And you know, this personally is important because otherwise people start reporting, you know, actors, football players, or politicians, whatever. And how many of them have been diagnosed or had symptoms compatible with COVID-19? We know that these are vague questions, you know, like, you know, there will be a lot of noise. We hope that the wisdom of the crowd will help us in order to compensate errors, you know, going up and down. So far, we are okay with the estimates that we're getting, but way more studies have to be done. I mean, we really don't know whether we're making mistakes. Essentially, the first question, you know, how many people you know, is what gives us what we call the reach. Essentially, it's like, you know, our sampling size. And the second one is how many people have symptoms or were diagnosed, is what we call cases. And then we apply something that at the beginning we didn't even know existed, or it was already posed, which is called the network scale-up method, which essentially, in order to estimate, in this particular case, the number of COVID-19, I mean, the ratio of COVID-19 incidence in a given area, what we do is we sum the cases from all responses and divide it by the sum of the reach of all responses. And this is something that, as I said, was proposed already in the 80s. In fact, the first, as far as I could tell, or at least as far as it was reported in this, in the documents we found, the papers we found, was done, was used in Mexico City for when they had a big earthquake in '85, in order to estimate the number of deaths. However, as far as we can tell, this is the first time that it's done online and is done at the scale that we are doing it, in the sense that, you know, it's global, and not only that, it's continuous. We are obtaining these responses and this participation continuously. So let me explain a little bit why this network scale-up method and indirect reporting works, and, you know, why it's helping. You probably already have an idea, right? So let's assume that we have this social network, or this network in which people know some others in the network, and I want to count how many. I want to estimate how many of these people, the ratio of people in this network, that either wear glasses or wear a beard. I did a manual counting. I hope I didn't make a mistake. What I counted is that there are like 24 such people out of 102. So the ratio I'm targeting is 23.5. If I do what is typically used in surveys, which is asking people, are you wearing glasses or are you wearing a beard? They can reply about themselves. So if I ask one person, in particular, this seems like a lady with the red hair, she will tell me that she doesn't. However, if I ask indirectly, how many people, including yourself, are wearing glasses or have a beard, then I'm covering an area of 7. and 2 of them are positive. So I'm already getting an estimate of 28.6% for my signal, for the attribute of the parameter I'm trying to estimate. If I ask again, in direct reporting, I get a 50% estimate. In direct reporting, I get a 21.4% estimate. If I ask a third time, I move to 25% estimate versus 66% estimate in the direct reporting. Observe that I'm counting twice the same persons, because the red and the green participants have people in common. But since I'm just estimating a ratio, that should not have much effect, unless there is a huge bias, unless I'm only asking people in one corner of the network. That should not have a big bias. And we still don't have analytical proof of that, and I must say that we still have a lot of work to do in terms of evaluating what the properties of this network method. But we have done some empirical study by simulation. So we created a couple of networks. One is the DBLP subgraph of the DBLP network, in which nodes are authors and edges are co-authorship. And we also use a Facebook subgraph with 4,000 nodes. And we we infect, let's say, in this network 10% of the network, and we apply this random sampling. Of course, we are using a uniform sampling, so this is important, because, as I said before, geographical bias could be an issue. And as you see at the bottom, the estimate, the red line converges very quickly, to 0.01, which is the right value. And if you see in the upper plot or the upper graphs, you see that the network, the error actually decreases much faster than when I'm asking directly people, okay, are you infected or not? Okay. So how did that work for COVID-19? Okay, so unfortunately, it was hard, or it is in fact hard to evaluate, with 100% guarantees. But we did one validation that we are in the process of doing, is comparing our results with different serology studies. So far, we have compared the results we get with a serology study that has been done in Spain. In fact, there have been already 3 waves of this serology study. The only one that has been reported in the journal, in the Lancet, is the very first wave. And so we compare our results with the results they get in this first wave. Essentially, what they do, I don't know how familiar you are with COVID-19. What they do is they do a quick test, fast test, detecting IgG antibodies, and then for most of the sample, most of the people that participate in the study, they also draw blood, and they did a more thorough test. I think it's like an ELISA type of test. It's supposed to be more reliable. What they're reporting in the Lancet is how many people were showing IgG antibodies in one test, the other, the intersection, and the union. So we're using the union because we believe that it is more comprehensive. And we're comparing it with our estimates, with the estimates we get from our surveys. And we're also comparing them with an estimate that we are getting using a technique that was introduced in this paper by Russell et al. In this paper, what they did is they assumed that the case fatality ratio, essentially how many people die amongst those who show symptoms, is known, and they use, and we use, the one that was reported in a paper a few months ago in Lancet from data from Wuhan, which is 1.38% CFR, case fatality ratio. And what they do is they estimate what is the case fatality ratio obtained from the public data. Essentially, the official data has number of cases, number of fatalities. They assume that the number of fatalities is reliably reported, while the number of cases is what is not reliably reported. They adjust by the fact that some cases that are reported have still not developed or have not been transformed into fatalities. That means that you need to take into account that delay, or that period in which you are overcounting the cases that or undercounting the fatalities. And by applying that, essentially what is being done is correcting the number of declared cases. So those are the blue and red dots that I'm showing here. The blue dots are the ones obtained with this CCFR or using the official reported data. The red dots are the ones that are obtained from our survey. The diagonal, essentially, in this axis, I'm putting in this axis the ratio for the different regions of Spain. So, like, for instance, Madrid is here. These 2 points here correspond to Madrid. This is the estimate. So Madrid has a reported incidence of a little more than 14%. The CCFR was a little below that, and our survey was a little above that. Yeah, I must say that we are both CCFR and the estimates from our surveys have been corrected, because the Lancet study reports, and there are roughly 34% asymptomatic. So we correct by that in order to be able to compare the total number of infected, or the percentage of the population infected. So you see, most of our points are in fact very close to the diagonal, which shows that the values that we are obtaining are very in line with the values that are obtained with this serology study. Then when we go to, I'm just zooming in the center, but I have the estimate for the whole country. And as you see, the estimate for the whole country from the CCFR is actually very good. It's almost it's almost exactly what the NCOVID study showed. On the survey, on the other hand, we are overestimating. So this is like 6.3, and we are a little above 7. I think it's 7.1 or so. This is not surprising, because this is obtained with only 600 and change responses. And in fact, some regions are better represented than others, and in particular Madrid and Castilla-La Mancha, which are 2 of the regions that were more heavily hit. These 2 regions in particular were the ones that, just because I live in Madrid and I'm originally from Castilla-La Mancha, I got more responses from those regions, and that is probably causing this over reporting of the percentage. But still, I think this is way better than what I was expecting. You know, I was expecting to be off by maybe a factor of 2, which, you know, was in any case better than the factor of 50 than I discovered in mid-March. So being so close is actually very encouraging, and this is something that is giving us a very nice feeling of what we're doing, right? As I mentioned, you know, this has been essentially what we did to obtain this estimate is we took only the 50 latest responses we got for every region, plus the 50 latest responses we got for the whole country, and just use those. No, actually, this is the average. We use only for this particular. We only use the values from the 50 latest responses from the regions. If there were not enough, there were regions in which there were not 50 responses. So that means that, you know, some regions are actually the estimates are actually with like maybe 20, 30 responses. When you compare this with the serology study that actually was done by recruiting 60,000 people, running 2 tests in each of them, they did 3 waves. We're only reporting on 1 wave. You have to deploy medical teams all over the country, and this team was engaged in taking samples over 2 weeks. So I think every wave of this study was probably €1 million or more. While for us, it was essentially, we haven't got any funding yet. I'll talk a little bit about that later if you want. But so this was essentially obtained for free. You know, well, you know, our time is worth something, I hope. But anyway, essentially the comparison of the cost of one and the other, this one study and the other is huge orders of magnitude. So we've been tracking. This report is from the summer. It's in July, and we have been testing different ways of using our data to obtain estimates, and we're still not happy with any of them. Initially, we used as soon as we were aggregating 30 new responses, we were plotting a point. And you see, this is quite erratic. And in fact, in Spain is overestimating, and again, it's because most of these responses were coming from Madrid. You know, I was very actively promoting the response. The surveys using social network, and most of my contacts are either Madrid or Castilla-La Mancha. We both are areas that are highly affected. This is the CCFR that I mentioned, and as you see, is quite stable. This is logarithmic, so you have to take that into account. And then we tried something else, which is use the 300 latest responses. And at this point in time, actually, that was giving reasonably good values. I'm talking in the summer. We have now discovered that, again, this is suffering for geographical bias. We take the 300 latest responses. Many of them are coming from regions that are overrepresented in them. So that's not a good solution. But so we're still working on finding the best estimate to apply. So the one that I was showing here is actually a good approach that we deployed, but we still need to fine tune. Something that is interesting here is that look at the gap between the estimate that we get, no matter which technique we use, with the percentage of cases that have been confirmed. So by end of July, there were less than 0.6% of the population confirmed. That was known by early May. It was already known. So we're talking around here. Early May, it was already known that there were roughly more than 2 million people infected. So, well, the number of confirmed cases that are being reported have to be taken with a big grain of salt. In general, what we found out is that in developed countries like Western countries, CCFR that uses the number of reported cases and fatalities and corrects the number of cases based on the number of fatalities is not bad. It's actually a good estimator. However, when we move to low and medium income countries, and I'm just showing Brazil, I have a couple more examples later on if you are interested. They're not in the main presentation. When you go to Brazil, what you see is that there is a larger gap here. CCFR, and we saw this systematically in other countries in which we got enough responses, like Ecuador or Ukraine. The gap in what CCFR is reporting and what we are estimating with our surveys is larger, and we think this is because the CCFR is using data that is not very accurate. In particular, fatality data is not very accurate. It seems like there are fatalities and are not being reported properly.